Scientists and physicists, welcome to this tutorial whereby we are looking at horizontal projection and we want to look at numerical treatment. We are given here a ball is drawn horizontally from the top of a vertical tower and it strikes the ground at a point 50 meters from the bottom of the tower. We are given that the height of the tower is 45 meters and we are required to determine the time taken by the ball to hit the ground. So to do that, we are going to employ this formula. S is equal to ut plus half gt squared. Now, when the body is projected horizontally, the vertical velocity is equal to 0. So we substitute 0 there to get S is equal to 0 multiplied by t plus half gt squared, meaning that our S will be equal to half gt squared. Now in this case, we are given S stand for the vertical height. So along the vertical direction, the horizontal velocity is 0. I mean the vertical velocity is 0. So you have 45, which is equal to half. G is 10 times 10 multiplied by t squared. So you have 45, which is equal to 5 t squared. We want t, so you have 45 divided by 5, which is equal to t squared. Dividing here by 5, you divide by 5 both sides. So t squared is equal to 9. 45 divided by 5 is 9. Take square root both sides. We take square root both sides. Square root of t squared is t. Square root of 9 is 3 seconds. So the time taken by the ball to hit the ground, it will be 2 seconds. 2 seconds. Part 2 of this question, the initial velocity of the ball. Initial velocity of the ball, we are going to consider also the same equation. S is equal to ut plus half gt squared. Now, we are going to consider now the horizontal aspect. Along the horizontal, g, acceleration due to gravity along the horizontal is 0 meters per square second. So you substitute 0 where you have g. S is equal to ut plus half 0 t squared. S is equal to ut plus 0 plus 0. Now, in this case now, the range is 50. So here we are considering the horizontal part. So R stands for the range is equal to ut. So 50 is equal to ut, t is 3, so times 3. We want u, the initial velocity, u is equal to 50 divided by 3. 50 divided by 3. Of course, this will give you 16 because of 48 remainder 2 over 3 meters per second, which can be written as 16.67 meters per second. Correct it to 4 significant figure. It is 16.67 meters per second. Correct it to 4 significant figure. Finally, the final consideration here, it is the vertical velocity of the ball just before striking the ground. Vertical velocity of the ball just before striking the ground. So to do that, it is simple. All what you need to do is to know this equation that V is equal to U plus gt. V is the final velocity, U is the initial velocity, G acceleration due to gravity, T is the time in seconds. Now, the vertical velocity of the ball just before striking the ground. Now, when we are considering the vertical velocity, it implies that in terms of the horizontal, U is 0. Along the vertical, the velocity of the horizontal is 0 meters per second. So we substitute here. V is equal to 0 plus G is 10 times 3. Our time is 3, which we found in part time taken by the ball to hit the ground in part 1 in Roman 1 of this presentation. So V is equal to 0 plus 30 meters plus that, meaning that V is equal to 30 meters per second. So that is the final velocity. So thanks so much for learning with us. Today we have considered a horizontal projection and we have looked at the numerical treatment. For other examples on the vertical projection and the linear projection, numerical examples, you can check in the link below so that you may see how they are added. So you need to keep on practicing. Also remember to subscribe to this channel so that you don't miss a single video which I upload every day. Bye bye. See you in the next study.